Here is another typical example or a typical problem of centroid or center of gravity. And what we're doing here is calculating the centroid of a half circle. The equation of circle is x squared plus y squared is equal to r squared. And as you can see, I have shown two methods of calculating the centroid of a half circle. The difference is, in one we are taking the differential area or the strip parallel to y-axis, and in another you are taking the strip along x-axis or parallel to x-axis. Just to make things clear, I'll write this x and this is y. So you have a distance y here, your total distance is y, and the distance to the centroid of the strip will be y by 2, and this is dx. And here you have dy here, and let's consider this as x because that's from origin. So the total distance of the strip or the length of the strip will be 2x. Now the differential area in this case will be dA is equal to dx into y, so that is y dx, and here dA is length into width, that is 2x into dy. Now we know the area of a half circle will be its total area of a circle is pi r square, so area of a half circle is pi r square by 2. And in the equation of centroid or center of gravity, we are using the total area from this equation because that will simplify your process. So you have your dA in both cases. Now from the equation x squared plus y squared is equal to r square, in this case you can take y squared is equal to r squared minus x squared, or y is equal to square root of r squared minus x squared, and that will be same in each case. So you have y here, and x in case of this equation you have x squared is equal to r squared minus y squared, or x equal to square root of r squared minus y squared. Now moving on, you know the centroid x bar will be integral x star dA over integral dA. Here the distance is minus r to plus r, that is you need to integrate between these two limits because you have taken the strip in this y direction. So your strip should move from this point to this point, so the integral limits will be minus r to plus r, and in this case you are moving from here to here, so that will be 0 to r. This distance is r, so therefore your integral limit will be 0 to r. Again, you can see there is a symmetry about y-axis because y-axis divides the half circle into two. So we know the x coordinate of centroid. The x coordinate is along this the axis that is passing through the center of the shape here. So you only need to find the y value of your centroid. So you have, instead of x bar here, you should have y bar, and that is y star dA over integral dA, and you know the y star is y by 2. Excuse me. So that is equal to y by 2, and dA is y dx into y dx over integral dA within limits minus r to plus r dA, and that should give you integral minus r to plus r y squared by 2 dx over pi r squared by 2. You know the total area is pi r squared by 2. And in this case you have y bar is equal to integral y dA over again pi r squared by 2. Let's keep this term away for the time being. Again, that will simplify your equation, and dA is 2x dy, so that is equal to integral y into 2x dy, whereas x equal to root of r squared minus y squared. That will give you integral y into 2 into square root of r squared minus y squared dy. We are keeping this term away for the time being, and we will take into consideration after finishing this integration. So this will be 0 to r, 0 to r. Now again, here we are not taking this term at the moment. So you have y square by 2 dx and pi r square by 2 within limits minus r to plus r. So you have, that will give you 1 by 2. You know y is root of r squared minus x squared. So y squared will be minus r2 plus r. Y squared is r squared minus x squared dx, and that will give you 1 by 2 r squared x minus x cube by 3 within limits minus r to plus r. You have this term remaining there. We haven't taken it into consideration here. We will take it into account later on. And here what you have is, you need to do the integration by parts. So let's assume u is equal to r squared minus y squared. Then du by dy is equal to 2y minus 2y, or that will give you du is equal to minus 2y dy. So substituting u in here, you have, if you rearrange this equation, you can write this one as minus of 0 to r minus 2y r squared minus y squared all raised to 1 by 2 dy. So you cancel the minus and minus, so you have a positive sign here. So this is given just to equate du is equal to minus 2y dy. You have du minus 2y dy, and that term is here, minus 2y dy, and you have u equal to r squared minus y squared, so that term is here. So you can rewrite this equation as minus of 0 to r u raised to 1 by 2 du. Now here you have 1 by 2, first applying the upper limit, that is r cube minus r cube by 3 minus r squared into minus r, that is minus r cube minus r whole cube, that is again minus r cube by 3. So that will give you minus r cube minus and minus plus, so you have 1 by 2, this is r cube, minus r cube, that will give you plus r cube, and minus r cube by 3, this is plus and you have a minus here, so you have minus r cube by 3, and here you have minus integral 0 to r u raised to 1 by 2 du, and that will give you minus u raised to 3 by 2 over 3 by 2 within limits 0 to r. Moving on, you have 1 by 2 2r cube minus 2r cube by 3, and here you have, you know, u is r squared minus y squared here, r squared minus y squared. So substituting the value of u in this equation, you have minus r squared minus y squared all raised to 3 by 2 over 3 by 2 within limits 0 to r, and that will give you minus r squared minus, put r here, that will give you r squared all raised to 3 by 2 over 3 by 2 minus r squared minus, substituting 0 here, 0 square all raised to 3 by 2 over 3 by 2. You have a minus sign outside there, so that will give you, and here you have, you can take this 2 out, so that will give you 2 by 2 r cube minus r cube by 3, that is equal to r cube again out, that is 2 and 2 cancel, so you have r cube into 1 minus 1 by 3, and that will give you 3 minus 1, that is 2 r cube by 3. And now you have a pi r squared by 2 in the denominator, so your y bar in this case is 2r cube over 3 divided by pi r squared by 2, that is equal to 2r cube over 3 into 2 by pi r squared, so that will give you r squared and r cube cancelled, so you have y bar is equal to 4r divided by 3 pi. So that is your y bar following the first method. And now let's see what happens on the second method here. So you have a minus sign outside, and this is r squared minus r squared, so you can cancel the first term, so 0 minus, this is r squared minus 0 square, so that will give you r squared all raised to 3 by 2 over 3 by 2, and that will give you minus and minus, that will turn to plus, r square raised to 3 by 2 is r cube over 3 by 2, that is 2r cube over 3. And again in this case you have the pi r squared by 2 in the denominator remaining, so your y bar will be 2r cube over 3 divided by pi r square over 2, that is equal to 2r cube over 3 into 2 by pi r square, again cancelled. That will give you y bar is equal to 4r over 3 pi. We will use this equation in many problems here on. So make sure you know the equation for, or you know the centroid for a half circle, and that is equal to 4r divided by 3 pi. If you have any confusion on how we reached this equation here or this one here, please go through the video where we discussed centroid and center of gravity. That video is shown here, centroid and center of gravity. That will give you a better understanding of the concept of centroid and center of gravity. So you have the centroid of a half circle as 4r over 3 pi. 4r